This is a 10-paper project presentation for our machine learning class, CSIS 3290. And the three project contributors are myself, Reily, Temitope, and Olumide. We are actually working on lung cancer prediction survey. So here is an overview and an introduction to our project. We all know that lung cancer stands as one of the most concerning health issues globally. And this data set that we chose will help us understand the risk factors that are associated with the diseases. So the data set that we are using is basically a compilation of responses that was obtained from a survey that was conducted by a university research team. The primary objective of this survey is to allow us delve into risk factors that are linked to development of lung cancer. We do this by exploring the demographics, the lifestyle, and the health-related data, and also the study that aim to shed light on the factors that contribute to these diseases. So here we'll be addressing few questions on why we're doing this survey and why we're doing the research. First question we'll be addressing is, how does the distribution of lung cancer diagnosis vary between genders? In this, we'll be also talking about the importance of why we are looking at this question. The visualization of these questions will be found later in our Jupyter Notebook files. So the importance of the first question that we choose, how does the distribution of lung cancer diagnosis vary between genders, is that it helps us understand if there's a gender-based difference in lung cancer diagnosis. And from the graph that we're going to be seeing later on in the Jupyter Notebooks, we could also be able to tell if the male or female has a higher number of risks in getting lung cancer. The second question that we'll be answering also, and also talking about the importance and showing the visualization, is how does the occurrence of lung cancer vary between people who smoke and people who don't smoke? And the importance is that it's going to also help us to examine these diagnoses based on the survey that was collected to know the crucial part that is involved in people who smoke and the risk factor that is also involved. We would also see from the visualization to understand the impact that it has on people that actually smoke compared to people that don't smoke. And then we have the fourth question that we are going to be answering also, how frequently lung cancer occurs for specific ages. This will help us understand the age distribution of individuals from the data set that we are using, how frequently specific age people can get lung cancer. So based on the demographic that was captured on the data set. And the last question that we'll be answering is, what is the relationship between income levels, ages, and lung cancer for different income categories? So for this part, what this is going to help us do is it will offer us the insight into how age distributions vary across different income levels concerning lung cancer. Based on the graph that the visualization that we are going to be seeing and sharing later on the Jupyter Notebook.
All right, thank you, Reily. Next, we'll talk about our data sets and some of the data ranking that we did before we went into our modeling. So we got our data set from Kaggle. The data set is a new one. In addition to use the data set was stemmed from the fact that it has limited utilization, and then the codes are very recent ones. Okay, And some of the important data set features that we had the gender that classified the client into male and female. We had the age spanning from 18 years of age to 90 years. And this will enable us to look at which age group is more at risk with lung cancer. Then we also look at the marital status. And then the data set we had 4 categories or 4 classes of marital status: the married, single, widowed, or separated. We also had children ranging from 0 to 5 years. And we have a very important data set for smokers, whether you're a smoker or not. And then we have other ones like employment status, the number of years worked, the income level, the effect of social media, whether it has any influence on lung cancer, and online gaming. And then we had the last feature itself, which is our target variable, the cancer column, to show whether it has our features predicted whether someone has colon cancer or not. So from the data that we had both categorical and numerical data. And so the first thing we had to do was to transform our data from categorical data to numerical ones. So initially we started with 12 variables, and then we had to convert our data, the categorical ones to numerical ones, using dummy variables. And then this moved our data variables from 12 to 15. Also, we thought to employ the use of feature scaling. And as we know that helps us to remove the biases and then remove outliers from our raw data. So we used the techniques of standard scaler, which is an inbuilt model from our library, and then available in Jupyter Notebook, and that helps us to scale our data. Then we also perform feature selections. We wanted to reduce our features from 15 down to a sizable number, because we know that this will help us, reduce some of the noise that we have in our data set. So we employed the use of the powerful resources from SKLN libraries to filter out some of our features, to remove the less relevant ones, and in order to reduce the noise from our data set. So we use the K-based selector, which is one of the techniques available in our SKLN library, and that helps us to, reduce our data set from 15 variables down to 10 variables. So I'm going to stop here to allow my colleague Olumide to take it from here, talk about some of the classifiers that we use, machine learning implementation classifiers, and our prediction that we used. Thank you.
Thank you very much, Temitope. I'll be taking over from Temitope and explaining the machine learning implementation taken in the course of our project presentation. And basically, we selected 5 classifiers. The first is the K-nearest neighbors classifier, the decision tree classifier, random forest classifier, naive Bayesian classifier, and support machine. So these classifiers are specifically selected to be able to help us achieve the best results in our implementation. We tested these classifiers, and because we realized that in the project description, you requested that we shouldn't use any deep learning implementation. So we decided to limit our classifiers to the classifiers that will be able to achieve this purpose. Moving forward, our best we decided to stick with the 5 classifiers because we realized that these classifiers help us to achieve a good result compared to the deep learning classifier that we selected initially. So, moving forward, we got our best classifiers as the RBF SVM classifier, which has an accuracy of 99.7%. And and it also has a cross-validation score of 77.3%, which is good for our prediction. So moving forward, we did a number of evaluation. The first was on the test set, the prediction on the test set. So we decided to stick with logistic regression since we're trying to not to work with the deep learning classification method. So we decided to use logistic regression. Our first classifier we used was the random forest, but we decided to stick with logistic regression. Now we got a test set accuracy at 79.2%. Then moving forward, we looked at the confusion metrics. In the confusion metrics, we have a number of evaluation. First, we have the true positive. True positive results gave the model correctly classified 9 positive class data points. Then the true negative, the model correctly classified 189 negative. No, the true negative, 198 negative class data points. Then we have the false positive. The model incorrectly classified 45 negative class data points as belonging to a positive class. Then for the false negative, the model incorrectly classified 7 positive class data points as belonging to a negative class. Then for the classification report, our precision out of the clients that we evaluated, that is from the data set we chose, the model predicted would get cancer. Only 81% did out of the predicted data that we used. Therefore, the recall, out of all the clients that we predict to get cancer, the model predict correctly to 96% of these clients. Therefore, the F1 score, since our value is close to 1, which is 0.88, it tells us that our model does a good job in predicting whether a client has cancer or not. Then lastly, for the support, this value simply tells us how many clients belong to each class in the test data set. We can see that among the clients in the data set, 54 did not get cancer and 196 did actually get cancer. Then we also evaluated out of sample prediction. So what we did here is that we generated a new data set. Then we tried to predict our model based on this new data set, and we saw the outcome. So I would show you our code and just give you a breakdown of what we did shortly. So moving forward to the code, we have the steps we took in the machine learning pipeline. So first we did the transformation, which is removing the unwanted data. So the unwanted data we have here is the ID. So we decided to remove that because it's not relevant for our classification. Then we have the domains. So we created domains for the categorical values. variables. Then we have the feature scaling. The method we use there is the standard scalar. Then we have the feature selection. So we decided to use the select k best, and we set our parameter to give us 10 features. So k equals 10. Then we have the data splitting. We did 75 to 25 ratio. Then our classifiers, which I've mentioned earlier, the logistic, the linear, SVM, the RBF, and the naive Bayesian. Then we have the cross-validation, which we use number of split equals 4, the k-fold cross-validation. Then we did our prediction. So moving forward, I would go to our classification, our prediction. So here we have the confusion metrics, which I've talked about earlier, which shows the true positive and true negative results. Then the classification report, which I've also explained earlier, shows the report here, and also the RC curve, which is here as well. So the insight we have in our classification, so basically if we are implementing for better results, we can try different variables to return a better result. So these are insights we can gain from our classification. So for the out of sample prediction, we first of all looked at our features which we selected earlier, and we created a new data sample which actually corresponds to the features that we created, which is this. Then moving forward, we decided to identify the categorical features and also change them to dummies so we can use it in building our model. Then moving forward, we decide to select the actual features that matches the features we selected in our model training. Then after selecting that, then we decide to predict. So this is our prediction. Our first prediction actually predicted that the client does not have cancer. So thank you very much for listening to our presentation. Thank you so much, sir.